Hey guys, welcome back to the channel, and in today's video we're going to build a React Native module that is written in C++ leveraging JSI. Now you may have a question. I hope maybe you know what JSI is, but maybe you don't. So for those that do not know what JSI is, JSI is basically an interface that allows JS to invoke native methods synchronously without serialization. So for example, we could write a C++ function or an object for a C++ object, and then we can access that object or function and call that function synchronously without having to serialize the arguments to the function and the response, like the return values from the function. And this is kind of what was built in the new architecture. In the old architecture, there was a bridge, and you can think of it like JavaScript and native were like server and client, and they communicate through JSON. Like when you need to pass something, you need to serialize it. Native has to parse it, do the processing, serialize again, pass, JS needs to parse. With JSI, you don't need to do any serialization, and you can just invoke things synchronously compared to the bridge, which was an asynchronous bridge. All right. And so, for example, when should you use JSI, right? To build, like, should you just use JSI because you can? So in my opinion, there are a couple of reasons of why you might want to do that. One example is wrapping an existing C++ library. Let's say someone else wrote a C++ library that works on iOS and Android, and you want to port this to React Native, right? You can use then a C++ module leveraging JSI to expose that. An example of such a library is React Native MMKV, which, as far as I know, wraps in a library called MMKV, which is written in C++. Another example maybe for performance reasons, like given that performance is needed and you tested like an implementation that you did in JavaScript, and then you tested a C++ implementation, and you really could notice a difference because you don't want to overcomplicate stuff, and you saw that this performance improvement is needed, then go ahead and use JSI. Another one is if you want, for example, to write native code, but only once. Because for example, if you've watched the previous video, like two videos that I've done, we created a React Native Turbo module for iOS and Android. Usually you'd want to use that when you want to expose platform-specific APIs, right? Because it's different on iOS and Android. But for example, if you want to write just native code that's the same on both iOS and Android, then you really can just use C++, right? You just write the code once. So in my opinion, these are some of the, like, are the reasons that I can think of. If you have more, just be mindful when just because you can doesn't mean that you should. All right. And in this video, I'm going to show you how to build as I said, a C++ module leveraging JSI for iOS. In the next video, like a video that I'm going to upload later, I'm going to show you how to do it for Android. We're going to continue like the work that we're going to do today. All right. So in order to start, kick things off, I'm going to use, like in the previous video, a library called Create React Native Library, which helps you create a React Native module library, whatever, right? The nice thing about it is that it gives you an example project that you can test your module on it, and this way you can iterate quickly. So let's just hit enter. I'll ask you a couple of questions. For example, the name of the package. I'm going to keep it as React Native JSI module, which I passed to it. Then says the description for the package. Add whatever you want. Just something's going to be like C++ module. And then the package author, the email address, URL, a repository. You can just hit enter on all of them. And finally, when it asks you what type of library do you want to develop, here you should pick. You don't have to, but what we're going to do here is a turbo module with backward compatibility, right? If you also viewed the other two videos, you'd see that we also picked the same one, because turbo module is how you build a module in the new architecture, and we're going to add a backward compatibility layer so that works on the old architecture. So let's enter. Finally, the language that we want to use is C++ for Android and iOS. and just here pick vanilla. One thing that I want to note here is that like after setting this up, this will not really build a C++ leveraging JSI. It is going to make it in like the old way. Like you could already make C++ modules, but not leveraging JSI using the old bridge, which makes most methods you implement asynchronous. So we can see that in a moment. So let's go into the library that we created and just run yarn. Okay, and now that this is done, let's just open up the project. I'm just using NeoVim here. Go into the example project, and I want you to do something just in the package.json. I want you to add in 2 scripts, right? Just pod new, and in here just say rct new r. I'm gonna explain this in just a bit. Just let me type that in, and then npx pod install, and then just do this one old without the rct new arc enabled. What we're doing here, we're just creating 2 scripts, right, that turn the new architecture on and off. The way that you would turn it on is that you would run like pod install with this rct new arc enabled equals 1 environment variable. So let's go ahead and leverage that and just do yarn pod pod new. That's what we called it. Now that this is done, let's go into the example project and now just run the app just to make sure that everything is running correctly. Most likely I'm going to get an error here. Usually I get this every time I start a new React Native project. I'm going to show you how to fix that in case you also run. Yeah, okay, failed, no worries. Let me go into the, so the thing is, you just need to get, if this also happens to you, go into the example directory, iOS, there's this file called .xcode.m.local. It just needs the path to node, Node.js. So just do which node, that's how you get the path. If you're on macOS, on Windows, I'm not really sure, you can just look it up and just add that here. Now let's run again. All right, guys, so the app was successfully built, which is a good thing. Now, what I want you to do is to go into, let's close everything here. And yeah. So let's just examine the folder structure, right? What's important to us, so this is kind of the module, right, with different directories, and there's an example directory, which contains a React Native app, which help us like test the library that we're creating just to make sure that if something is working or not, right? What's important to us in this video is the source directory and this iOS directory and the CPP directory. All right, let's go into the source directory and check out this native JSI module. Now, this native JSI module is adding a spec, like a specification for the module that we are creating. I go into more depth into this in my 2 previous videos. You can take a look at these. But basically, here you just specify what does your module does, right? In this case, when the example project was made, there was just a function called multiply that takes in 2 numbers and return a promise of a number. Now, if you remember in the beginning of the video, I said that this like example module that was generated is not really what we're going to build. It's not a JSI, like doesn't leverage JSI, because as you can see, it returns a promise. Like, let's think about it for a minute, right? It's just a multiplication function. You take in 2 numbers and you multiply them. Like, there's no need for it to take a long time for it to be a promise that needs to be resolved, right? It just A times B, return the value, right? So it should have been more like this, right? But as I said, the module that's generated, like that's created in this kind of example, is not what we're going to build. What we're going to build is synchronous, no serialization needed module, right? All right, so let's change the spec to what we want. So let me explain to you something here about what we're going to do. we're not going, what we're going to do is we're going to add a function, only one function, all right? Even though our module that we're going to create is going to have multiple functions, right? We're going to go into like more detail of what our functions are going to do that we're going to implement. But for now, we're just going to implement one function. And what does this function do? Let's just add in the how it looks like, right? The interface. All right, we're just going to have one function called install. It's a function that takes no arguments and return a boolean. All right, so what does this install function does? What this does is that we're going to invoke this like in our native module. And what's the responsibility of this function is really to attach functions written in C++ to the global JavaScript object. All right. So that's the entire function of this install function. It doesn't even like this is not something that the users of the library will use, right? This is something that will be called just once when the library is imported, and when it's called, we're going to attach the functions to the global JavaScript object, and that's how we are going to attach, like as we said in the beginning of the video. JSI is an interface that allows JS to invoke native methods synchronously. Now, how can JS invoke this native method? There should be a way that JavaScript will be able to kind of have a hold on those like functions or objects, and that's by attaching them to the global JavaScript object. And that's how it's currently done. Like in the Act Native, if you check out open source libraries, you're going to see that that's the implementation that they do. There is an improvement of this one, and that's not like the long-term solution that is expected of React Native. But for now, like that's the current kind of industry standard and what everyone is using, right? Again, we're just going to have one function, and this function is going to attach all of the other functions, all right? And the reason it's returning a Boolean is just because it's going to kind of help us. We're going to return either true or false from this function natively. And if it's false, then we know that something went wrong. If it's true, then we know that the methods were successfully attached to the global JavaScript object. All right. Now that we changed that, let's go into Xcode. All right. So in order to write our library, all right, we're going to code inside Xcode. And it's just because when you're writing like iOS code, it's like Objective-C, for example, it's best to use Xcode in my opinion. So in order to open up Xcode, go into the example directly and run xed iOS, okay? And inside here, just go into the pods. Then development pods. Then look for your library here. Like for me, it's React Native JSI module. For you, it's whatever you named it. And in here, there is a header and an implementation file that was created for us. So let me show you how where this is in the regular like directory structure. It's under iOS. So here there's this JSI module .h and JSI module.mm. And these are exactly these ones. Now the H file, you don't really need to edit that, but just for your own knowledge, the H file is just where you would kind of add in the interface, right? So and here we are creating an interface that that's subclasses NS object and implements the native JSI module spec. Okay. Let's now, if we go into this native JSI module spec, we're going to see this multiply function, all right? But since we changed the spec, and when I say spec, I'm talking about this one, all right? Since we changed the spec, we need to run yarn pods new again. And that's how like the new spec gets generated for us. Here, Xcode will prompt you if you want to read from disk or if you want to, let's check. Yeah, just say that it says that something changed, just say read from disk, right? And now if we check the spec, we're going to see our install function. All right, that's good. That's what we want. Next, let's go and delete this all, let's go into the JSI module.mm and delete the multiply function, right? Because we are no longer doing the multiply. And now we are, it will show you like in a warning that we are not conforming to the protocol, like this protocol, right? You can just say fix, right? And ask it to fix, like just fix it for us. In here, for now, just return at yes, okay? And that's just how you would return a Boolean that the React Native can understand, right? So let's add in here. So here it expects an NS number, like a pointer to NS number, but in JavaScript, this is a Boolean. That's how it's represented in Objective-C. And in order to return true or false, you would return at yes or at no, okay? But for now, just let's leave it at yes. Okay, so next, now what we're going to do is we are going to add our C++ implementation, right? Now, this is where we're going to add in our C++ functions. And what we're going to edit here is this CPP file, right? So there are these two files, the H file and the CPP file. And again, H file is where you the kind of declare your API, and CPP is where you do the implementation. So these are also available for us here, CPP. So let's go into the header file. In here, there's this namespace JSI module. Let's just remove the multiply because we are no longer doing multiply. We are going to have an install function that's going to accept one argument, right? And the argument that this is going to accept is the JSI runtime, right? Because we need to pass it the runtime, and inside the function, we are going to attach the functions to the runtime, like to the global JavaScript object. And the way that you would do that, first we need to include the JSI headers. So I'll do jsi.h, and then we will add in the parameter, which is Facebook JSI runtime, and we will take a reference to it, and then JSI runtime. All right. If this at is a bit confusing to you, and that's just how you would do references in in C++, right? In JavaScript, when you pass an object or an array, for example, to a function, it's always passed by reference, right? But in in C++, that's not the case. If you don't pass this, like if you don't specify an and, for example, like this, it's always passed like as a copy, all right? If you add the and, then it's passed by reference, and we want to pass it by reference. One thing that we can do is, instead of typing Facebook JSI runtime, we can say, since Facebook is a namespace, we can just say using namespace Facebook, and then we can just delete this part, just to make things kind of a bit shorter, right? This will be more useful in the implementation file. Now that we specified our kind of API of our C++ module, let's go and edit the implementation file. Now, let me just explain something here, right? We have an install function in C++, and we have an install function in Objective-C, which is iOS, right? The reason why we have two is that in iOS, we need to invoke the C++ install function, and also in Android, we need to invoke it. So we need to have like a central place, which is C++. And then for iOS, we also have another install, which calls delegates to the C++ install. And when we do the Android, hopefully in the later, like in the other video, you're going to see how we have like a similar thing. We call the Android install function, which calls the CPP install function, which attaches all of the function. All right. Again, let's go back to the implementation now of our module, which is this one, React Native JSI module.cpp. As you can see here, they added the implementation of the multiply function. We can just remove that and copy in this one. Okay, did not copy it. No, we did. All right, let's include JSI, JSI.h, and let's do using namespace Facebook. All right, now in here, we need to actually add in the implementation. In order to now implement this, what we're going to do is we are going to create the functions that we want, and then we are going to attach them to an object, all right? And then this object we're going to attach to the global function, to the global JavaScript object, all right? So let me just quickly show you like what I mean, like just as simple as possible. We're going to create an object, right? And let's call this my module, right? Equals JSI object. And when we are creating a JSI object, we need to pass it the JSI runtime, right? So actually one thing that you're going to notice is that in most JSI kind of methods, you need to pass it the runtime over and over again. So it's a bit tedious, but we'll have to do it, right? So here we created an object, and then we do JSI runtime dot global dot set property, and then we pass the JSI runtime, we pass in the name of the property, and let's name it underscore underscore my module. And I'm going to explain that in just a bit. And then my module. All right. So what did we do here? All right. In this line, we created a JavaScript object, all right, in C++, all right? So that's kind of similar to doing const obj equals to, that's what we're doing kind of here, all right? And what we're doing here is we're getting the runtime, we're accessing the global object, and then we are setting a property on it. And the property we are setting is underscore underscore my module underscore underscore, and we are passing it this module. So what this is doing now is something like this. Underscore underscore my module equals to object. All right. So imagine like these are JavaScript code, and this is exactly kind of what they're doing. And now, so the reason why we are creating this underscore underscore my module is because when we are attaching our functions, our C++ functions, we don't want them to kind of pollute the global object, right? We're only going to add in one property, and inside this property, we're going to add in all of our other all of our functions. We don't want to add in a property for every function, then we would be polluting the global object like a lot, which is not a good idea. One thing also to keep in mind is that we need to wrap this in std move. Why do we need to do the, I think we need here a closing parentheses. So why do we need to do this? Now, when we create an object, all right, usually objects are like variables, non-dynamically allocated like variables are kind of deleted or destroyed at the end of the scope, right? So for example, you define something here, and then at the end of the function, this my module is going to be destroyed, right? Which makes sense, right? This is our install function. That's where my module is defined. The function finishes. There's no need to keep this this variable anymore. It gets destroyed, right? But the problem is that we need to access my module from JavaScript, and it's going to outlive like this function call, right? So in order to make it outlive this function call, we need to move it, right? We're just telling C++, just move this from this scope to the scope of the calling function. All right. Now we need to, let me check my notes here. Yeah. Now we need to define our functions. Let me just increase the font size in case that was not very clear. What we're going to do now is we will start now to define actually the functions. All right. And the functions we are going to define, let's just write them down so you guys know what we're going to do. Let's go into our source. of the module and then into index.ts, right? Okay, so let's clear out maybe this multiply because we will no longer use that. And the functions that we want to expose are the following. Let me just search snippets, exported functions, okay? Let's do const module equals to global dot underscore my module underscore. Okay, so these we are going to implement these functions. Okay, a function called reverse string that takes in a string and returns. We need to return here. And we are expecting it to return a string. Let's add in the return value here. All right. And then a get numbers function that returns an array of number, and the get object function that returns a record of string, which is just an object. And then we'll have a function called call me later, which takes in a callback, like 2 callbacks, and then calls either one or the other. And then we'll have a promise number function, which takes in a number and resolves it, like resolve the number that was passed in. So what I'm trying to kind of show you guys here is how to do like multiple stuff, right? Taking like a primitive input, return a primitive output, return an array, return an object, accept callbacks, do promises, like just everything that you kind of, like most of the things I'd say that you can do with functions, right? And as we said, we will be able to access our module or like the functions from global.__ my module__, because that's what we did here, right? We are setting the object into this property of the global object. Yeah. Okay, I think that's good. Let's go ahead and now implement the functions. All right. I'm going to paste in JSI function. All right. So this is, I'm going to go through this now line by line, but that's kind of the basic way of how to add in a, like create a function. Okay, let's go through it line by line. So first we are defining a variable, okay, which is called function name. Let's call it reverse string. Okay, so we are defining a function called reverse string, which is of type of JSI function, all right? And the way we create that is we call JSI function create from host function, right? So this is just a method on the function class. And then this method accepts 4 arguments. It accepts the JSI runtime, which we have it. It accepts something called like a prop name ID, which is kind of just a name given to the function that's usually internal to JSI. And what you want to name this one is usually the same as the function name. So in our case, it's just reverse string. So I just recommend that you just name it the same thing. Finally, the third parameter, not finally, but the third parameter is how many parameters or arguments this function is expected to like receive. So in our case, reverse string is supposed to accept 1 parameter, which is the string we need to reverse. So in this case, we just set this to 1. Finally, we need to like kind of now here define the actual function, like the implementation. And this is done through a lambda function, all right? And a lambda function is just very similar to JavaScript anonymous functions. And it's actually pretty similar syntax, except for these square brackets, which I'll explain later. In here, you have this opening and closing parentheses, which define the parameters. And then this is the return type. And finally, you can return, like this is the body of the lambda function. All right, let's go through the arguments. The first argument that we receive is the runtime. The second one is the this value, which is the JavaScript this value for the given context, we're not going to really use this one, so you don't really have to worry so much about that. Arguments is a pointer to an array, or like a pointer to the first argument that is passed to this function, right? So basically this is what we use to access the arguments that are passed in, and count is just the number of arguments that are passed in. Finally, this function needs to return a JSI value. Now, what is a JSI value? I hope I can go into here. Yep. So if you check the definition, it just says represents any JavaScript value. So it could be anything, undefined, null, Boolean, number, literally just anything, all right? So it's just a generic type. And in our case, we're just returning undefined, just here as the example. Finally, we are going to set this function. We don't need to set it actually on the global. Let's change this and just do it on my module. Oh, my module. And then this is reverse string, and this is reverse string. So what does this line do? All this line does is it takes this my module, which is an object, right? And it sets a property on it called reverse string, and the value of this property is the function. It's just this function. And that's it, guys. That's how you would define a function, right? Now we're going to still add in the like implementation of the function, but that's the general way of how you would define a function. So let's copy this, right? And paste it for the amount of times that we need it, right? For all of the other functions. So as we said, we have 5 functions. So let's paste it 5 times, or like 4 times, because this is already 1. So that's 2, 3, 4, 5. All right. Now let's go ahead and change the names. The name of the second one, let's put these a bit side by side so we can see them. So the second function is called get numbers. All right. Let's now replace. And how many arguments does this get numbers array like function takes in? It doesn't take in any arguments, so we just say 0. And then here we change the name of the property, and we say that the value is the function that we just defined. Then we have get object, right? Copy, change here. How many arguments? It's 0. Doesn't take any arguments. Change this one and change this one. Then there's call me later, which takes into two callback functions. Oh, let's copy this one, change here, and the number of arguments that this one takes is 2. And finally, like here, we change these two to be call me later. Same thing, promise number, which is a function that takes in a number and resolves it. Basically, change this, promise number. How many arguments does it take? Takes in 1. Change this one and change this one. And with that, we just defined an empty implementation for all of our functions. Let's go in and add in the actual implementations now. All right. So for the first one, let me go ahead and check my notes here. Should be an easy one actually. Okay. So we said that we need one argument, right? Like there should be one argument that's passed in. So because JavaScript is a dynamically like a dynamic language where you can pass in anything, any number of arguments, no one cares, right? We need to validate this, all right? So we need to validate the arguments. So let's say if count is not equal 1, or argument 0 dot is string, but this should be not, right? So if count is not equal to 1, and if the first argument is not a string, we throw an error, which is JS error, and we pass it the runtime, and we say argument has to be a string, right? So that's how you would throw an error back to JavaScript. You would create a JS error from JSI, pass it the runtime and the string that you expect, right? Next, let's define the string, std string, another colon here, str equals to, now that we validated the argument, we could say as string takes in the runtime dot utf8 and pass the runtime. So in order to convert a passed in string, you would call the as string dot utf8, and now we have a string. All right, and next we need to reverse it. So let's do std the way that you would like. This is really just now C++ really, but the way that you would reverse a C++ string is you would do std.reverse str.begin str.end, and that's it. And now we need to return it, but in order to return it, we need to return a JSI string. And to return a JSI string from our C++ string, we would do JSI string create from UTF-8, and then we pass in the runtime, we pass in our string. Yep, so as we can see, like in order to convert a JSI string to a C++ string, you do the as string.utf8. In order to convert the string, like a C++ string to a JSI string, you do create from UTF-8 and you pass it the string. And that's it. Reverse string is done, guys. Let's do get numbers. And the way that we're going to implement get numbers is really just define an array, like fill it with 10 numbers and return the array, right? So just imagine this as doing whatever processing you want, having like a response of an array and then you return it. But just for the sake of this video and not making it too long, which it's going to be anyways, I'm going to have it just be an array of 10 numbers. So to define a JSI array, you would do JSI array, call it array, equals to JSI array, and then you pass in the runtime, and then you pass it the size. Since we want 10, we say we pass in 10. Then we can just return array, all right, just for the error. And then here we just do std size underscore t, I equals 0, I less than 10, plus plus I. Now, the reason why the type of I is std size underscore t is just because usually when you are dealing with indices in C++, the type that's used is size underscore t. So, and because we need to index the array when we are putting stuff inside it. So we say array dot set value at index. As you can see, the index is of size, of type size underscore t. So we do set value at index, we pass in the runtime, we pass it the index, which is I, and then in order to put an integer inside the array, we need to, as we said, like here, as we said, we can pass in like a JSI value, which is JSI value, which, as we previously said, it represents any JavaScript variable, right? So we can just use a JSI value in this case and pass in I, right, which is the number. But I is of type size underscore t, and JSI value doesn't really know how to create like a JSI value out of a size underscore t. We need to change it into a integer. And the way that we would do that is just do a static cast to int and pass in I, right? And with that, we are good. That's it, guys. Get numbers is done. Let's do get object. Get object is kind of similar. We do the same thing. We create an object, we set a value inside it, we return it. So let's do that. We create an object with JSI object and call it obj equal JSI object, pass it the runtime. Let's return object, and then object.set property. We pass in the runtime. Then what's the name of like the key of the that we want to set? You can do whatever you want. I'm just going to have it be result, and the value has to be a JSI value. So a JSI string is also is acceptable as a JSI value. So we do JSI string, and we say we do create from UTF-8, right? When we need to pass it a string, we pass in the runtime, and we pass in success, for example, right? Like that's what we did in the previous video. So what this does, it just assume we have a JavaScript object and just adds in a key of result and value of success, right? Just for the sake of example, really, you can do whatever you want. And that's it, guys. Get object is done. Let's go on and do call me later now. With call me later, we need to do a bit of like checking the arguments again, because we have two arguments. We need to check that they are functions, right? So in order to do that, we do if count is not equals to 2, or arguments. I don't know why I say or. It's just like pipe, right? Two pipes is an or, but I say or like I don't know really why, but so if not, argument 0 is object, or not arguments 0 dot as object runtime dot is function runtime. Let me just paste in and I'll explain this in a moment. So what we're saying here, so in order to check it's a function, we first need to check that it's an object. So we check, is it an object? And if it is, then we say as object dot is function. And that's how you check if a function is passed in. Now, if this failed, that means the user did not provide like two callback functions. We throw an error of JS error and pass it the runtime. The message is expected two callback functions as arguments, right? You just let the user know. Now, let's get hold of those two functions. JSI function, success, CB equals to arguments 0 as object, runtime as function, runtime. Like now we know that it's a function, so we can just access it, right? And then we can do failure callback equals to arguments 1 as object as function. Now we have two callbacks, and now we can do success cb dot call, right? And pass it the runtime, and failure dot call and pass it the runtime. However, just to make it a bit more interesting, let's okay, so we need to return something. Let's just return undefined, right? Because like there's really nothing that we want to return here, so let's return undefined. Nice. So as I was saying, instead of just calling both of them, let's generate a random boolean, and whether it's true or false, we call either one or the other. So to generate a boolean, we do like a boolean called call success, like whether to call the success callback or not. We just do std rand modulo 2. So std rand would give us a random number in a given range. I don't really remember what it is, and it doesn't really matter. And we do a modulo of 2, which returns 0 or 1, because the variable we are defining is a boolean. It's going to be casted to a boolean. If it's 0, false, 1, true, right? And now we do if call success, right? Else, put here, and this, put here, right? Let's align, space them. Nice. Guys, we're done with call me later. Now let's do promise number. This is kind of the most complicated among them, so I left it till the end. Yeah, let me check here my notes. Okay. So what we need to do, guys, here is something that's interesting. First, let's just validate the argument. That's the first thing that we need to do, right? If like the argument that's passed in that we're expecting is a number, so let's check that. If count is not equal 1, or arguments 0 is number, we're going to throw, right? JSI, JS error. And in here, we pass in the runtime and say expected one numeric argument. All right. Next, let me explain here a bit what we're going to return, basically. Let's take a look at promises, just JavaScript, right? Let me zoom in here. In JavaScript, to create a promise, you to create a promise at the very basic level, you would call the promise constructor with the new keyword, like new promise, and then you pass it one argument. And this argument is a function that takes in two arguments, the resolve and the reject, right? And then you call either resolve or reject. So that's what we're going to do here, all right? So let's get hold of the promise constructor, right? So the way that we would do that is by doing JSI function promise constructor equals to runtime global dot get property as function runtime and promise. Okay, so what we're doing in this line is we are getting a hold of the promise constructor. Like, think we are getting hold of this thing, kind of, all right? Like the constructor of the promise, basically, of the promise. And finally, in here, we need to return this promise, like return an instance of this promise, right? Like we need to create a new promise and return it, right? So we're going to be like promise constructor dot call as constructor, all right? And then we pass in the runtime. And in here, what does the constructor accept, guys? Like, as we've already said, we called the constructor, perfect. So this promise constructor dot call as constructor is we are calling this new promise. And then it accepts a function, right? This is just a function. So we just need to define another JSI function, right? And pass it here as an argument. So let's go ahead and do that, right? JSI function create from host create from host function, and then we need to add in maybe I can use the snippet that I had, snippets JSI function, right? We just don't need this one, right? And delete this line. Guys, I hate Xcode and how it aligns stuff. Let's see. Let's remove this assignment like this, and let's see if now. Okay, now this JSI runtime should be called runtime, and we need a semicolon here. Anything else? Also JSI runtime here needs to be runtime, right? Are we good? Yeah. So what we are doing here really is we are adding this create from host function as an argument to the call as constructor, all right? You can change this one to be really just promise arg or whatever you want. Next, we say the number of arguments. Again, promise constructor provides two arguments, which is the resolve and the reject. So we change this to 2. And yeah, with this, we now can just get hold of the resolve function. We say JSI function resolve equal arguments 0 dot as object runtime dot as function runtime runtime. Now the reason why we don't really do validation on these parameters like directly we did as object as function, you can do validation if you want, but since we are grabbing the promise constructor and like just standard of JavaScript is that when you call the constructor, you get 2 arguments. So it's like that's a given. So you don't really need to do. So this is arg actually. Now that we have the resolve function, we can just call resolve.call and then pass in the runtime. And because we said we want to resolve the number that was passed in, right? Like this function promise number takes in 1 argument, which is okay, so we did the validation here, but let's define this number. Double number equal arguments 0 to as number. We get this number and we said we're just going to resolve it. Again, just for the sake of example, think of this as just defining a function that takes some time and then returns a value. But just for the sake of example, we're taking in a number and resolving it, right? Now we'll have an error here, and it says variable number cannot be implicitly captured in Lambda with no capture default specified. All right, so what does this mean? This finally brings us to this square brackets here. And usually in JavaScript, right, if you have a function, all right, so let's, yeah, so you see how, for example, in JavaScript, you have this function and how it can access variables that are defined outside the definition of a function, right? So it captures the stuff that are outside. And this also happens with anonymous functions in JavaScript. However, in C++, in Lambda functions, that's not the case. So double number is defined here, but you cannot access it here like directly. You need to specify it in this square brackets, right? You either need to specify that you want to copy it here, or you want to reference it, right? And in our case, we're just going to add in here number, and we say just copy the value here so we can use it, right? And with that, we are done. We defined all of the functions. Hopefully we don't have any errors. I mean, we've done a lot of stuff, so maybe we have an error. We're going to check later. Finally, guys, what we need to do now is we need to go back to this file. Let me show you. We need to go back to the iOS directory to the implementation of our module. All right, so let's go and do that here in Xcode, iOS, and here. Now, when we call install, what we want to do really is call the install function that's in our C++, which attaches all of the functions. So in order to do that, we need to import our C++ module, which is React Native JSI module.h. We need to import JSI .h, and we need to import React RCT bridge plus private. Okay, and now inside this install function, we need to get a hold of the runtime, right? Because our function expects a runtime to be passed to it, the JSI runtime. So we need to get a hold of it and then call that function. So let's do that. First, we need to do RCT bridge. Okay, get a pointer to the bridge using RCT bridge current bridge, and then we do RCT C++ bridge and C++ bridge equals to, actually, I think I have a snippet for this one. Let me check my snippets, guys. Yep, CPP installation, nice. Yeah, so we get the bridge, and then we get using the RCT bridge.current bridge, and then we cast the bridge to an React C++ bridge, and then we check if it's nil, we return no, like something wrong happened, like there should be the C++ bridge. And then we get the runtime by calling C++ bridge.runtime, and we cast that as a runtime. Again, we check if it's nil. If it is, we return no. finally, we can here invoke our install function. So we say JSI module install, and we pass it the JSI runtime. Now, JSI runtime is a pointer. Our function expects it to be a reference, so we dereference the pointer. And with that, we're good. One more thing we need to do is we need to wrap our like kind of our function or our method in a macro, which is rct export synchronous start method. And what's yeah, okay, yeah. So what you do here, like simply just wrap everything except of the curly braces with rct export synchronous type method. The first argument is the type that we return, and the second argument is the name of the method, and any arguments it takes no arguments. So it's just install. All right, nice. And with that, I think, guys, we're done. All we need to do now is we need to go to the example project, go to the source, and then app.tsx. And in here, let's delete this multiply. Let's delete this multiply stuff. And in here, I'm going to paste in a snippet that just uses function test. It just kind of adds in a button, right? And what each button does is just call one of the functions. So this function calls reverse string, passing in the string reverse string to reverse it. And then there's one to call get numbers, that's imported. There's one to call get object, another to be for the promise, right? And finally one for call me later. We're passing it two callbacks, right? Let's delete the unimported ones, like no need for them. One last thing, I guess, is we need to go to the source of our module, to the index.tsx. And in here, this is our module, right? Like this is our spec, this module that's exposed through the spec, right? So what we can do is we can really type this as spec. And we have only one function here, which is the, if you check JSI module, we have the install function, all right? So what we're going to do here is we're going to say if global dot underscore underscore my module, like if it's not defined, right? And okay, we don't have to actually. Yeah, if it's not defined, let's call JSI module dot install. Yeah, install. All right. So what we're doing here is we are checking if this underscore underscore my module is like defined or not. If it's not defined, that means we haven't installed our like C++ methods. So we call install, which calls this one, which calls the install of the C++. And finally, we are setting the variable module to be global dot underscore underscore my module. And then all of the function really just reference this one. So guys, hopefully if we don't have any errors, let's go ahead and just run the project. npx react native. Yeah. Now, hopefully now when we run the project, it should work. So let's see. Okay, guys, so the app was successfully built, and the moment of truth. Reverse string, nice. We get reverse string reversed. Let's try get number 0 to 9. Interesting. Get object, result success. Promise. Okay. Promise number is not a function. Let's check if we messed up something here, guys. Get number, call me later. Oh, so we had a typo. Prom C number. No, it's promise number, right? Let's go ahead and copy that. and put that everywhere and change it here and here. And with that, let's run the app again. Okay guys, we fixed the typo. Let's try it again. Nice, promised value is 5. And finally, callbacks. Success. Let's try to call it multiple times because there's randomness there. Success, failure, whatever. And let's make sure that the previous ones did not break. Okay, cool guys. Everything's working fine. Synchronous functions, callbacks, promises, async await, everything, right? And when I say async await, I'm talking about this promise number, right? We're calling it, you can use async and await, and it just works. Now we need to just test it, that it works on the old architecture, right? And how do you know that we are on the new architecture? Is by checking when you run the app. Let's reload it. You see how there's this concurrent true, fabric true. You see this fabric true. When you see this one, that means you are running on the new architecture. Now let's stop and let's run yarn pod old, right? We added these scripts in the example project package.json here. And to run the app in the old architecture, you just run pod install without passing any environment variables. Let's do that. And now that this is done, here Xcode asks us to, if you want, let's read from disk. And let's run the app again now that we switched to the old architecture. All right, guys, so we switched the old to the old architecture. I ran yarn pod, and then I ran the app again, and now we no longer see this fabric true. And now let's test it. Also, another one is that previously you would see that it says no bridge, and now you just see log without the no bridge. So that means we are on the new old architecture. Let's test them again. Reverse string works, get number, nice, get object, cool, promise, wow, callback. Yep. And with that, guys, we just built a C++ module in React Native leveraging JSI, doing synchronous calls, no need for like serialization. Showed you how to do like primitive inputs and outputs, arrays, objects, callbacks, and promises, right? And now in the next video, we're going to do Android because I decided to do iOS in this video because usually iOS is simpler. It may seem that this video may be more complicated, but because we set up everything, we did the C++ code and everything. In the next video, we're just going to continue from this place where everything is set up for us, right? The example app is set up for us. The C++ code is set up for us. The index, right? The spec, everything is set up for us. So Android may seem a bit simpler. We'll see. But yeah, if you like this video, please just give it a like, subscribe if you'd like to see my future videos, and please let me know down in the comments, like what did you think about this video? Do you think my explanation was clear? Maybe there are places where I could have improved. And if you'd like to see other videos in the future, just let me know down in the comments. And yeah, thank you guys very much for watching, and goodbye.